Hello everyone, let's go ahead and talk about chapter 13, homework problems. First one, which if any of the following features common to soaps, detergents, phospholipids and channel forming antibiotics. So we talk about soaps, detergents and phospholipids in the lecture videos, so you guys can choose the correct answer based on that. The first one, they all contain fatty acids. Their function depends on the dual polarity of their molecules. All contain phosphate groups, contain polypeptide chains. None of these choices are correct. There is a correct choice, but it's easy to figure it out. You can also watch the video. Also, it talks about how the cleaning happens, when you use a detergent or soap. So we talk about that. So you should be able to figure that out. Okay. Number 2, consider the expression below showing the terms which contribute to the heat of a solution. Normally, heat of solution is an exothermic process because it decreases the energy of the system. But there are other factors also contributes. So to find out the delta H of the solution, we need to take into consideration delta H of the solute, solvent and also the mixture. So we talk about in the lecture videos, normally delta H solute is going to be always endothermic, meaning it absorbs heat when the solute particles separate. Same thing for the solvent, when the solvent particles separate, it also absorbs heat. So that's both of the delta H solute and the delta H solvent are going to be endothermic process. But the delta H mix, when the solute and the solvent mix together, it releases heat to the surrounding in an exothermic process. Okay, so the delta H mix therefore going to be less than 0. It's negative. So you choose the one that would say delta H solute positive, delta H solvent positive, meaning greater than 0, and the delta H mix going to be negative, meaning less than 0. So delta H solution could be either positive or negative based on the size of these amounts. Okay, but always a solute and the solvent will be positive, but the mix, when they are mixing, it's going to release heat. Okay, so number 3, which of the following sets of conditions could exist when two liquids which are completely miscible in one another are mixed? The two solvents you have, they are completely going to be soluble with each other. So what happened to the delta H and entropy? So in a situation like that, delta H or the enthalpy of the solution, since they are going to be completely miscible, delta H solution would be similar to 0. Okay, almost similar to 0. And the entropy of the system will increase because now the solvent particles, since they are mixing with each other, they have more degree of freedom of movement. Okay, so choose the one that says delta H solution almost 0 and the entropy of the system increases. Number 4, if a solute dissolve in an endothermic process, what happens if a solute dissolves in an endothermic process? Strong ion dipole forces must exist in the solution. Hydrogen bonds must exist between solvent and solute. The solute must be a gas. The entropy of the solution must be greater than that of its pure components. The entropy of the solution is immaterial. So the correct answer is going to be the entropy of the solution must be greater than of its pure components if a solution dissolves in an endothermic process. Okay. Number 5. just letting you know, I did this video, the whole thing, and then I did something, it didn't save, so I had to do it again. Anyways, so number 5. The Henry's law constant for carbon monoxide in water 25 degrees Celsius is 9.71 into 10 to the negative 4. How many grams of carbon monoxide will dissolve in 1 liter of water if the partial pressure of carbon monoxide is 2.75? How do we approach this one? This is what we're going to do. We talk about the Henry's law in the lecture videos, and you will find that the Henry's law gives us the solubility. So you can find out the solubility of a gas equal, so this is a gas, and Henry's constant given as Kh times the partial pressure of the gas. So what we want to find out is how many grams of carbon monoxide will dissolve. So the Henry's constant is given as 9.71 into 10 to the negative 4. The units are moles per liters per atmosphere, and then the partial pressure is given as 2.75 atm. So atm will cancel. It's asking how many grams of carbon monoxide will dissolve. Basically, that's a solubility. If you keep your answer like this, it will give you moles per liters, but you want in 1 liter, what is the mass? How many grams? How do you convert moles of carbon monoxide to grams? Using the molar mass. So 1 mole carbon monoxide is the molar mass of carbon monoxide. Carbon is 12, oxygen is 16, so 28 grams, right? So you convert 28 grams. Okay, so this will give you the solubility in terms of grams. Okay. Number 6. Soda drinks bubble when the bottle is opened. Have you thought about the reason why it happens? You all drink sodas, right? When you open it up, it bubbles. Why is the reason? What is the reason? Is it the partial pressure of carbon dioxide above the solution is reduced? Think about the pressure difference. Which one has more pressure? Carbon dioxide. Is it inside the can of the soda? Pressure is more, or outside pressure is more? Where do you think has more pressure? Inside the can or the atmosphere? More pressure would be inside the can, right? So it bubbles because now you are creating a pressure difference of the carbon dioxide or the gas trapped inside the Coke or your soda, right? So the partial pressure of carbon dioxide above the solution is reduced. In fact, that is the reason that soda drinks bubble when you open it. So there, first one is the correct answer. Okay. Let's look at the other one, B, C, D, E. Henry's law constant changes due to the change in the pressure. No. The temperature of the soda increases. No. Atmospheric nitrogen molecules displace carbon dioxide molecules. No. Exposure to atmospheric pressure squeezes the carbon dioxide from solution. That's not correct either. So we found a correct answer. Okay. Okay, number 7. Potassium hydrogen phosphate. Used in powdered creamers. Calculate the molarity of a solution prepared by dissolving 238 grams of potassium hydrogen phosphate enough water to produce 275 milliliter solution. Molarity. Molarity, not molality. Molarity, we know molarity equals moles over liters. We have done so many questions similar to this in Chem 1, right? We are given grams. So 238 grams, 238, I missed the 8 part. 238 grams we need to convert it to moles. Find the molar mass of potassium hydrogen phosphate. So 1 mole would be, M here stands for the molar mass. Molar mass of K2HPO4. That will give you number of moles. And once you find the number of moles of K2HPO4, molarity is so you take that number of moles and then you're going to divide it by the volume, 275 milliliters. You want to make it liters. So by basically dividing 1000, we'll make it to liters. Divide by 275 liters. Moles you get from this calculation. Divide by 0.275 will give you the molarity. Okay. And then number 8, also similar question that we have done in Chem 1. Calculate the molarity of a solution prepared by diluting 1.85 liter of 6.5 molar KOH, potassium hydroxide, to 11.0 liters. So this is a dilution reaction or dilution process. So we can use M1V1 equals M2V2. Remember we use this, M1V1 equals M2V2. Right? So you can consider your M1 as 6.5 molar KOH, and then the volume 1.85 V1, and then the volume 2 would be 11, volume 2, and then you can find out the M2, the concentration. Okay. Number 9. What is the molality? Now remember here it is not molarity, molality. Molality is symbol small m. The way that you calculate the molality, you take the number of moles of the solute and you divide that by the mass of the solvent, only the solvent, not the solution, in kilograms. It has to be in kilograms. That's how you calculate molality. What we have here is our solute diethyl ether. It has to be in moles. First you need to calculate the number of moles of diethyl ether, that is going to be 86.9 grams. You take the molar mass of diethyl ether, you can calculate that, C4H10O grams per moles. Find out the number of moles. Excuse me. And then you're going to divide this by the mass of the solvent in kilograms. So 0.425 grams is, mass is going to be 0.425 kilograms. That will give you M. So you calculate the number of moles using this part and take that part and then put that number of moles calculation over here. I just put 1 to represent there is something there, and then you divide it by 0.2425 kilograms. That will give you the molality of the solution. Okay. The next one, the solubility of the oxidizing agent potassium permanganate is 7.5 gram per 100 gram of water. What is the mole fraction of potassium permanganate in this solution? So the mole fraction, let's say if you say the mole fraction X is number of moles of substance A that we are interested, you divide by number of moles of A. The same thing plus the number of moles of B. If you have one more thing, if you have another component, that would be number of moles of C, like that. That's the mole fraction. So we are here considering two components, potassium permanganate and water. So you need to find out the number of moles of potassium permanganate in 7.1 grams. Okay, how do you convert again grams to moles? You guys know that it's easy. You take your 7.1 grams, you divide by molar mass of potassium permanganate. You can calculate that. Molar mass will be in grams per moles. That will give you moles KMnO4. And similarly, you find number of moles of water. Moles water would be, there are 100 grams. So 100 grams, 18 grams is the molar mass, 1 mole water. You find the number of moles of water. So moles potassium permanganate, from here you calculate the moles water, and then you take moles and you take that moles KMnO4 that you calculated, you divide it by that same number of moles KMnO4 plus the moles water. That will give you the mole fraction. Okay, that is number 10. Number 11, the concentration of iodine in seawater 60 parts per billion by mass. Let me erase this so I can use this space. It's given in parts per billion. Do you know what is parts per billion? What is billion? How many digits are there for billion? Is it 6 or 9? Million is 6, right? Billion is 9. So it's telling us the concentration is parts per billion by mass. And if one assumes that the iodine exists in the form of iodide anion, what is the molarity of iodide in seawater? The density of the seawater is given. Okay, parts per billion, ppb, represent however many parts in grams. In this case it's 60. Billion is 10 to the power 9. What about million? Million is 10 to the power 6. Grams per, since it's a billion, 10 to the power 9 grams. However many things per 10 to the power 9 grams. If you consider ppm, parts per million, would be however many things in grams per 10 to the power 6 grams. Okay, so this one ppb, it says 60. So when you're writing the units for the ppb, 60 parts per billion, so you put the 60 grams on your numerator and the denominator would be 10 to the power 9 grams. And if you are given a question ppm, you put however many amount over here in grams and you divide by 10 to the power 6. So basically here what is asking is you convert the unit ppb to molarity. So what are our molarity units? Big M, molarity normally is moles per liters. So our goal is to convert this unit, both grams in the up and down in the equation, convert to moles per liters. Let's see how we're gonna do that. So 60 grams, that's iodide, right? So iodine, right? Grams we need to convert to moles to get the moles into numerator. What do we need to do? We use the molar mass of iodine. Iodide molar mass is 127. So 127 grams per mole, that's the molar mass. And now we converted grams to moles. So the top part, numerator, we took care of. And then the bottom is grams. We need to convert to liters. How do we do that? and the density of the seawater is given as 1.025 grams per milliliter. What about if this is water? If it is water, it would be 1 gram per 1 milliliter. So you can use that conversion. Since it's seawater, 1.025. So we can convert these grams to milliliters using that density. So 1.025 grams per milliliter. Okay, we are almost there. Now we need to convert milliliters to liters. How do you convert milliliters to liters? Milliliters here in the denominator. So 1000 milliliter is 1 liter. So milliliters get cancelled. So we will have our answer in moles per liters. So basically you will be multiplying 60 times 1.025 times 10 to the power 3 over 10 to the power 9. Okay, this will give you the answer in ppb. If you were given a question with ppm, you will follow the same thing, but instead of 10 to the 9 you would put 10 to the 6. And since this is seawater, you use the density for the seawater. But if it is water, it's just going to be 1 gram per 1 milliliter. Okay, so the last one. A solution of ethanol in water, sometimes used as a disinfectant. 1 liter of this solution contains 553 gram of ethanol and 335 gram of water. What is the molality of the solution in this solution? Remember, the molality is moles over the mass of the solvent. Just the solvent, not the solution, in kilograms. Okay, so contain 553 grams ethanol. If it is given in grams ethanol, we need to convert it to moles. So 553 grams, you use the molar mass of ethanol. 1 mole ethanol is the molar mass of ethanol. I think it's 46, but you guys can calculate and figure it out. 46 grams, convert into number of moles, and then you divide it by mass of the solvent, 335 grams, converting it to kilograms, 0.335. We can just put 1 there, kilogram. That will give you grams to grams cancel. Okay, that will give you the molality of the solution. Okay, that is our chapter 13 homework.